Hi, I am Asghar, and in this video titled The Linux File System Table Explained, I will present an analysis of the file system table file, popularly known as the fstab file, that stores a one-line entry per file system and swap area that are to be mounted or activated at system startup. The concept, use, and format of this file applies to other mainline Linux distributions and their clones as well. For more details and for help with RHCSA, RHCE, CompTIA Linux Plus, and LPIC-1 certification exams, see my latest publications as shown on the slide. Linux stores data in file systems, which are created in disk partitions or logical volumes. Linux also makes use of optical file systems that are available on CDs and DVDs. Most of these file systems need to be mounted automatically at system restarts to ensure that the data they contain become available for users, applications, and programs as soon as the system is up. At the time of Linux installation, one swap area is created, and this swap area is used by the kernel when needed. On large Linux systems, we may find additional swap space areas configured. These swap areas need to be automatically activated at system startups to ensure that the kernel as well as any applications and programs on the system use them as required. For automatic mounting of file systems and automatic activation of swap areas at system startup, the file systems and the swap areas must be defined in the fstab file. This file is located in the etc directory. The fstab file must contain proper and complete information for each listed file system and swap. An incomplete or an inaccurate entry may result in an unbootable system. The fstab file is edited by hand, so care must be observed to avoid syntax and typo errors. Let's take a close look at this file and analyze various pieces of information that it stores. This file maintains a one-line entry per file system and one-line entry per swap area. Each line is broken into 6 space-separated fields. The permissions on this file are typically world-readable and root-writable. Let's see what kind of information the fields store. Field number 1 defines the device file name of the disk partition, the logical volume, or the optical device where the file system or the swap is resident. For example, /dev/sda1 is a disk partition. We may instead use the universally unique identifier, the UUID, or the label associated with the file system or the swap. For logical volumes, we use the device file paths, such as /dev/mapper/centos-root or /dev/centos/root. And for optical devices such as a CD or DVD, we normally use /dev/cd-rom or /dev/sr0 in this field. Field number 2 identifies the mount point for the file system. It should be an absolute path to an empty directory. For swap areas, this field can be set to either swap or none. Field number 3 specifies the type of the file system or the swap. For file systems, we may see an entry like ext2, ext3, ext4. For extended file systems, XFS, VFAT, or ISO 9660. For swap areas, the type swap is used. There is another type called auto is available that we can use instead. This type will allow the file system and the swap commands to automatically determine the type. Field number 4 identifies one or more comma-separated options to be used when mounting the file system or activating the swap. Explicit options such as read-write, read-only, and so on may be used. However, in most cases, you'll find the option defaults in this field, which includes several common options. Field number 5 is used by a Linux utility called dump to determine the file systems that need to be dumped. A value of 1 enables this check, and a value of 0 or nothing in this field disables this check. This value is set to 0 for swap areas and for file systems that do not support this feature. Field number 6 is the last field, and it indicates the sequence number in which to run the file system check utility called fsck. A value of 0 disables this check. A value of 1 is used for the root file system, and a value of 2 is used for file systems that are created in disk partitions or logical volumes. This value is set to 0 for swap areas and for file systems that do not support this feature. Let me bring up my CentOS and Ubuntu systems and show the fstab file contents. cat/etc/fstab, and that's my CentOS system. And there are several entries in this file defined. /dev/mapper CentOS root is the logical volume device file for the root logical volume, which is created in the CentOS volume group. The mount point in the second field is the root directory. The type of the file system is XFS in the third field. All the common options, and 0 and 0 in the fifth and the sixth field. For the boot file system, which is created in a disk partition, we have this UUID defined for it. The mount point is /boot. The type of the file system is XFS, defaults 0 and 0. This is the swap area, which is created in the CentOS volume group. There is no mount point. We use swap, or we can also use none in this field. And this is the type and default 00. /dev/lab_vg lab_lv1 that I added in my previous YouTube video. The mount point is here. The file system type is this. And this is another file system that I created in this disk partition. Mount point is /testbar. File system type is ext4. And field number 5 is set to 1. And field number 6 is set to 2. And these two are swap areas that I created in my previous YouTube videos. And on my Ubuntu system, cat/etc/fstab. There are currently 3 entries in it. The first one is the root logical volume. Name of the logical volume is root, and the name of the volume group is Ubuntu-VG. The mount point is root. The file system type is ext4. And instead of the defaults, we see this option here, which means to remount this file system in read-only mode if there are any errors encountered when the system tries to mount this file system at boot. The UUID is for the partition that is created in a disk partition, the boot partition or the boot file system. The file system type is exe2, and we're using all the defaults here. And this is the swap area, which is also created in the Ubuntu-VG volume group. The name of the swap area is swap_1. There is no mount point associated with it, so we use none or swap here. The type is swap, and this is an option that is used only with swap devices, and 0 and 0. There are only 3 commands that I know of that use the fstab file, and none of these commands make any changes to this file. This file is always edited manually by hand. The commands that reference the fstab file include the mount command to mount a file system, the swap_on command to activate a swap, and the find_mnt command to look for file system information. And that's it. This brings us to the end of this video. I suggest to review the manual pages of the fstab file for additional details relevant to each field. And here's a list of my other YouTube videos on Linux available for free. Visit my website www.nixeducation.com for information on my books, tutorials, and available trainings. If you like this video, please give it a thumbs up and share it with your network. Please subscribe to my channel NixEducation to get notifications of my new videos. Thank you for watching.